All right, ladies and gentlemen, it's time to learn to move with the keyboard. So let's get moving. That's so funny. Let's get moving. All right, here's what we're going to do. Create a new C# script called first person scenario input and attach it to the player. And here's the deal. Why do we do that? So the question is this. So look, we already have, so I have, by the way, I have way more scripts than you have, so you don't need this many because I have a bunch of different versions of it. But look, we already have mouse look, so, and that he helps our guy move around. Why are we going to create this thing called first person input to move around with the keyboard? And see if you can figure that out. Okay. Okay, and here's the code. Here, but by the way, let's go back. Why do we do that? Well, the answer is this. It's way more flexible. So if you have a thing for moving around and you have a guy for looking around, like let's say if you have another character, well, you can, and you only want him to be able to move around but not look around, well, you could add the one script and not the other. So because remember, we use this component system, and you can drag and drop these guys on whoever you want, so it makes it way more flexible. Okay? All right. So here's the code we're going to add. Add this code and try it out. We should be able to move around using the arrow keys or WSAD. But what is wrong? So play around with it and see what's wrong. Okay. So go ahead and get that far. But here I'll show you. I'm going to hit play. And so look, we can look around. And now let's see what happens if I use the arrow keys. Oh, wow. What's happening? I can move through walls. Okay. So I shouldn't be able to move through walls. So let's figure out what's going on with that. Okay, all right. By the way, I guess I should talk about it. This is where we declare and initialize an instance variable, public float speed. So we have a box called speed. The only thing that can go into it is a float, right? And if we initialize it, we stick 6.0 f in there. Okay, so that, by the way, that f turns it into a float instead of a double. Okay, these are local variables right here. So right here, I'm making a box called delta x. Delta means change. And same thing, you can put a float in. But this is in the void update, right? Because I'm declaring it in the void update inside the actual method. It becomes a local variable. So this thing will last forever. This thing goes here, 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 and by the time you get down here, these all disappeared because you already used it. Okay, anyway, just a little so you know. All right, answer this question. Write this down. All right, declaring a variable to create an empty box with a name and a data type. That's declaring a variable is making an empty box. Initializing is sticking something into the box for the first time. An instance variable is declared in the class, but outside the. Anyway, write this down. And why is delta x a local variable and speed an instance variable? That's an interesting one. And the answer is because this one needs to last the entire time. We always need to keep our speed constant. But this one, we get it, we use it. Right, so we transform it using the change in x and y, and that's why. Okay. Control mapping. How does Unity know? By the way, how does it know how to use the arrow keys and the WASD? Well, here's how it knows. It's kind of built in. Okay, so if you go to Edit and you go to Project Settings and then you go to Input, you can see right here. Let me maximize this thing here. So you can see right here it knows. WASD, so the A is for the horizontal movement, vertical is the SW, the up and down. So it's all built into it. Okay, so that's how it knows it. So you can change all this, by the way, if you want. So that you can use that to control like the Xbox controller and how everything is controlled. All right, setting a rate of movement dependent. So I don't know if you knew this, but the way we have it set up, if you go to a faster computer, it's going to move, your guy's going to move faster, and on a slower computer, it's going to move slower. So the player will move twice as fast on a computer that gets 60 frames per second as it would on a computer that only gets 30 frames per second. We need to fix this because you don't want your game to do that. You want it to work the same on every computer. So you're going to change your code right here. We're going to put in this delta time. By the way, so let's talk about this real quick. So here's what you do. You find out the delta stands for change. So you get the change in x. And then you say, hey, what's the change in x? And you get the input, the horizontal input, and then you multiply it by your speed. And then you get the change in y from getting the input from vertical, right? So we figured out how it knows what vertical and horizontal are before. And then we're going to use our transform guy, but now we're going to times it by time.delta time. All right, so the time class, this guy right here, has a number of methods useful for chiming things, and time.delta gives us the time between frames, so we know how fast it is, and it helps kind of equalize it, right? By the way, write this down. Delta means change. So anytime you're in physics or science, delta means the change. So what are we trying to get? We're just trying to get how much change has happened, right? Okay. We are not using our built-in collision detection module, so our character will pass through the walls. We already found out that he passes through walls. These changes aren't going to fix him going through walls. So we need to use our character controller and use its collision detection. So let's add some code. So by the way, if you hadn't already done so, let's go here. So if you hadn't already done so, we did this before. We added the character controller. So if you don't have a character controller, that's bad. You need to do that right now. Here's how you do it. Here's how you do it, by following these instructions right there. Okay, so here's the code. So look, we're declaring an instance variable. So private character controller, character control. So we have a box called character control. The only thing that can go into it is a character controller. All right, so we're going to initialize an instance variable. So we're going to say, hey, our box called dash character controller equals get component character controller. So basically, we're getting, because this guy is attached to our player, and so is this code, right? So this code is attached. So this code right here, first person input, and this character controller attached to the code. So when we say get character controller or get component, it's like looking, all right, let me look at all the components over here, and we're going to try to get the character controller. So now our box called character controller is holding this guy in it. So now we can talk to the character controller. Okay, why are we doing that? Because the character controller is built to control characters, and most of the time our characters don't go through walls, and he's going to help us with that. Okay, so now look, so we change our code. So look, hey, what's the change in X? What's the change in Z? Now we're going to stick it into a this guy. I think we're talking about this later. Maybe we're going to talk about this later. So if not, I'm going to come back to and explain this to you. All right, so look, here's how you declare a variable. Hey, who can use it? This one's private. It can only be used by this script. Okay, if it's public, everybody can use it. What is the data type? The only thing that can go into our box, we're making a box named dash char controller, right? That's the name of our box, and the only thing that can go to it is a character controller, right? So we have an empty box right at the moment. So this creates an empty box named character controller that can only hold something of the class character controller. Okay, and then in the next thing, we initialize it. We're going to say, hey, our empty box is going to be equal to, so we're going to stick something in it. Hey, let's get that component, and we're going to stick it in there. Okay, the character controller already exists elsewhere, and we don't need to make another one, so this is actually just a reference to it. So what we're saying is this. So we're putting this guy in this box, but he already exists over here. So he already exists, so we don't make another one. We just say, hey, this guy exists here, and he also exists here, so we're just putting like a reference. So this really is like an arrow going over here to this guy. So when we talk to dash char controller, we're actually talking to this guy right here. Okay, so the get component method returns other components attached to the same game object, right? And we already talked about that because this script is attached to our player. He can get this guy who's also attached to the player. All right. Why do we initialize this variable in the start method? That's a good question. Answer that. And the answer is we do it in here because we need to do it one time at the very beginning, right? So we need to once we start this guy up, we need to get it one time after when everything starts up. So this is a good place to do it. Okay, we need to get our movement into a vector 3. So basically, because we're eventually going to use our character controller down here to do the movement to keep us from going through walls. He uses a vector 3, so we've got to get all of our movement into vector 3. So we need to get all of our movement into the vector 3 so that we can use the vector 3 class to make tweaks below with our character controller. Limit this code right here, vector movement equals vector 3 dot clamp magnitude. This basically keeps your x and your z moving the same amount. So you don't want to move really fast on the x-axis and slow on the z-axis, so it keeps it the same. Okay, so look at all this. So we're getting our change in x, our change in z. We're sticking it into a vector, and then you're clamping it down so one's not moving faster than the other. And then you're taking the movement in your vector 3. So you have your x, your y, and your z. And then you're saying, hey, I want them all to run all the same on every computer. And then we're going to talk about this one later. So make a tweak here, and then finally we're sending those three movements, the X, Y, and Z, to your character controller, and he'll allow it to move, but now he's not going to let it go through the wall. Okay, by the way, the times equal, this guy right here, takes the first guy, movement, and sets it equal to itself. So basically we're saying movement equals movement times delta time. Okay, so that's how we're getting the movement the same on fast and slow computers. All right, so far the vector 3 is a local movement dealing with the player's left, the transform direction. This guy right here changes it into a global movement, so it does some work for you. So again, we're doing all this work on movement, we're setting up movement, we're tweaking it, and then finally we're saying, hey, character control, I want you to move this movement, the X, Y, and Z. Now we can use the global movement here, and the character controller will make sure that we can't walk through walls. Okay, so try it out. Let's see what happens. All right, so we have this new code, so let me hit pause here. Let's hold on. Okay, so I'm going to, I'm doing it different than you, so hold on 1 second. So I'm going to delete this guy. You don't need to do this. This is just for me. Okay, so here's the one that you have. So, all right, so I'm going to add, so this is what we have. So I'm going to add this guy to it. So this is the same thing we've been doing. Let's take a look at what it looks like. Okay, here's the code you should have. Okay, so your code should look just like this. Okay, and now so now let's run it and see what happens. Okay, so we look around. Let's see if we go through walls. Aha! We can't go through walls. This is good. Okay, now, is there any bad thing that can happen? Oh, yes. I can fly. I believe I can fly. I'm flying all around into the sky. That's bad. We don't want our guy to fly into the sky. So let's see what's going on here. Let's see if we can stop that. Okay, what is still wrong? He can fly. What axis do we need to adjust to keep him on the ground? Well, which one is the up and down? Well, that would be the Y, right? So here's what we do. So in real life, everything accelerates. Everything is constantly moving towards the center of the Earth, 9.82 meters per second. So if you dropped a ball out of a plane, after 1 second, it would be going 9.82 meters per second. After 2 seconds, it would be, what's this plus this? It would be like 18, 19 something. It would be going, after 2 seconds, it would be going 19 meters per second towards the center of the Earth. But that, since it's down, it's a negative, right? So we're going to create this new instance variable that represents gravity, okay? And it's very close to what actual gravity is. And then now look what we do here. We're going to add this code here. So we're going to say movement.y. So now we're adjusting our y, because before we'd always set y to 0, right? So we had we're saying, hey, well, there's no movement. Now we're saying, yeah, we're constantly moving down towards the center of the Earth, okay? And that should help. All right, now test it to see how it works. Okay, let's see what happens here. Okay, so now we have here we have this. This is what your code should look like now. So you've got the changes here, so you can copy this. We make sure you save it. Make sure you save your changes. Now we run it. Let's see what happens. Let's see if we got it this time. All right, so I can move around. Am I a ghost or not a ghost? I can't go through walls, and let's see if I can fly. I cannot fly, which is good. Okay, so the cool thing would be is if you could get this guy to jump. That might be a fun little additional project. Okay, so let's see what is next. Okay, so we got it. Okay, so here's a chapter summary. 3D coordinate space is defined by X, Y, and Z axes. Objects and lights in the room set up the scene. The player in a first-person scene is essentially a camera. Basically, it's like a block or a capsule with a block on it, with a camera on his head. Movement code applies small transforms repeatedly in every frame. So just like a movie, everything moves just a little bit each frame. First-person scene controls consist of a mouse rotation and then a separate keyboard movement. All right, here's your quiz. Answer these questions. I expect that you will answer all of these. I will quiz you on it. Okay, so take some time and answer these questions. And the next step, show your project to me for a grade. Take the pre-practice and real test, turn in your notes after the real test, and then go on at some point to lesson 3. And if you don't know what lesson 3 is, I will help you. That is the end.